Okay, we're going to use the first derivative test here to find out where this function has a relative maximum. Could have a relative minimum, I guess. But to find a relative max or min, we want to find the critical numbers of the function, which means we want to find out when the first derivative equals 0 or is undefined. So the derivative of this first constant term is 0, of course. And then here we have to use the product rule. So I'll call this the first function, 2 plus x, and e to the minus x is the second function. So it's the first function times the derivative of the second function. That's e to the minus x using the chain rule times minus 1. And then plus the second function, e to the minus x times the derivative of the first is just a 1. And what I did here is factor out a minus e to the minus x from both of these terms right here. That leaves 2 plus x from the first term and a minus 1 for the second term. And when I simplify inside the parentheses, I get an x plus 1. So we want to know, when does this expression equal 0? That's how you find the critical numbers. So here I've set it equal to 0 using the zero product property. This expression will equal 0 when either this factor equals 0 or e to the minus x equals 0. Well, e to the minus x never equals 0. So it'll only equal 0 when x plus 1 equals 0 or x equals negative 1. So that's the x value where we might have a relative maximum. We'll use the first derivative test to find out. Put the critical number on a little number line. There's the negative 1. And then use test values to the left and to the right of that critical number to determine whether the first derivative is positive or negative in those intervals. Pick a test number in each interval, like negative 2 is to the left of negative 1. If I put a negative 2 into the first derivative, picture it right here, I'll get negative e to the second times a minus 1. That's going to be positive, greater than 0. And that means the tangent lines are going uphill, so the original function is increasing. And likewise, if I pick a number to the right of negative 1, I see that it will always be negative because e to the 0 is 1. And I got this minus sign here. That tells us that the original function is decreasing. So there's a relative maximum at negative 1, increasing to decreasing. And if I put negative 1 into the original function, this is what I get for the coordinates of the point that has a relative maximum. If I share my screen and go to Desmos, here's actually the original function. If I take the derivative that we use there, let me get rid of this for a second, and use the Desmos derivative operator, you can see that I get the same graph. So I'm convinced that this is a correct derivative. I'll recopy or re-enable the first derivative, and I'll re-enable the tangent line, which is I've let x sub 1 represent any x value. And you can see that that green line is actually a tangent line to the graph of the original function. And I'm using the g function to calculate the slope. And x sub 1, f of x sub 1 are the x and y coordinates of a point on the graph. Okay, so right here, when x is negative 1, the slope is 0. And I get this horizontal line, and guess what? This 3.718 is e plus 1. So there you go. Hope that helped. If you have any questions, post a comment.